Hello, my name is Paul Jenkins, Managing Director of UK Packaging Innovation Consultancy, ThePackHub, and I'm delighted to be joined today by Dr. John Williams, Director of Aquapak Polymers. Hello, John, how are you?
I'm fine, thank you, Paul, and thank you for the invitation to speak.
Really excited to find out a bit more about you and what you do. So without further ado, can you tell us a little bit about yourself and what you do at Aquapak, please?
Yeah, so I'm the Chief Technical Officer, so my responsibilities are research and development, and that's both internal and external projects. So we have a lot of relations with universities, etc. I'm also in control of the technical side of IP and related issues and technical transfer, and of course QA as well falls under me.
Excellent. And you've been developing some specially engineered materials with Aquapak, creating a bit of a stir in the market over the last year or two. Tell us a bit more about Aquapak and what your solutions are.
Well, I mean, we started with a polymer that's been around a long time, which is polyvinyl alcohol. And what we've done is perfected the thermal processing of the material at all hydrolysis levels. So you can get different functionalities, different performance criteria out of different combinations of that. So we can basically play tunes on that polymer. We combine it either, it can be used on its own, or we combine it with other materials, conventionals or biopolymers in different combinations to give you different functionalities, really. So that's really what's, I think, causing the interest, because you've got that combination of high functionality that obviously the packaging areas demand. But also you've got some interesting multi-functional end-of-life possibilities depending on what constructions you want to actually create.
Okay, I mean, obviously in the last couple of years or so, single-use plastics has been, I think it was the word of the year in 2018, maybe 2019, and tell me a bit more about how the market has developed and how that's opened up opportunities for Aquapak.
Yeah, it's been interesting because obviously there's been, well, in my view, a disproportionate amount of noise and sometimes irrational noise around plastics. But I think what it's opened up really is perhaps the consideration for how best to use these materials, either in combination with themselves or with other materials, with the end of life goal as well as a functional goal in mind. I think we've kind of skirted around it over the years. We've kind of talked about recycling and recyclability, but then it's sort of morphed into the difficulties of that and getting it through the supply chain. But I think what this is focused with things like ocean plastics, the talk about microplastics, and then of course single-use packaging directives and plastic tax, etc. I think it started to focus the whole of the supply chain on including the designers of, okay, actually, what can we do to give the consumer ultimately what they need in terms of, say, food packaging or conventional packaging, but also with something in mind that says, hey, there are better ways of dealing with this once we've used it.
Okay, absolutely. So drilling down a bit more in terms of Aquapak's specific solutions. I mean, you've got the Hydropole. I mean, that's your sort of the main product, as I understand. I mean, tell us a bit more about how it works, its applications, what markets it's in. Just give us the full SP.
Sure. Yeah. Well, I mean, principally we are the pellet producer. That's what we do. So we have a brand new facility in Birmingham in the UK that produces that material. But where we started was very much sort of fairly simple monolayer blown films. So specialty bags, soluble bags, cytotoxic bags for hospitals because it's got excellent pathogenic properties, etc. That's where we started. So we actually started that with lots of converters in Southeast Asia, which is now our first commercial products that have been now going for 2 years or so. And that's kind of ticking away. But that obviously then moved us on to more technical materials. So laminate films, and latterly, and coaxes and things like that. So combinations with existing materials to make those materials either more functional or at least equally functional to what they're used to, but also giving them an end of life in terms of recyclability or biodegradability, if that's what you need. as an attribute to that. But what we've moved on to later, I think this is quite the interesting one, is as the brands particularly have sort of been a bit nervous about on the plastic side, they've driven more towards paper and paper combinations. Well, clearly you still need functional paper. You can't just use paper for all the packaging applications that we're used to. So you still need barrier, grease barriers, fat barriers, oil barriers, oxygen barrier, you need heat seals, etc. And that's where hydropoly is really actually starting to play quite heavily, because it's got a real synergy with cellulose and cellulosics and paper. And now we can direct, as well as laminate, we can directly extrude onto those type of substrates. Then you end up with a functional paper material that can be used conventionally on standard machines, form, fill, and seal lines, for example. But you have an end of life which actually goes straight into the paper stream, goes through the paper mills without a problem. You know, we've done a lot of work in this area improving that out, and some of you may have seen our joint developments with DS Smith, for example, where we've taken it all the way through to 100% fiber recovery, which is clearly what the mill wants from the economic side of it, but without any detriment to the mill chemistry or their waste issues. You know, clearly what they don't want is plastics entering their streams and then causing issues in their system. So they don't want lots more plastic entering their mill systems, catching on their screens, which they have to then dispose of at a cost, or it contaminates their structure. So that sort of circle of the paper side with the conventional sort of converters, and also the brands is really taking hold now. I think with hydropoly, it's a big push for us.
Okay, and do brands fully understand how it works and the opportunities for them? Because it just sounds an amazing way of delivering sustainable packaging to me.
Yeah, I mean, clearly, like all these things, as you enter the market with something new, that you have to go through the hoops of proving it, and that's why, to be honest, we had to put in equipment into our plant in Birmingham, which is not commercial equipment in the sense of we're selling material, so films, extrusion coating equipment, etc. Just simply because the rate determining step is often the converter, because clearly they're busy, you know, they've got stuff to do, and running trials with new materials is often a bit of a challenge, even if they're pushed, as they often are, by the brands to do that. So we've kind of taken that step away from them and said, well, we'll do that. We'll demonstrate it works. So you've got a confidence level that this material will run on your equipment, and also to give, obviously, pilot scale equipment, material rather, to the brand to say, yeah, there you go. Is that what you're looking for? Go test it. Here's the migration data. Here's the taint data, the odor data, whatever you need, tensile data, and I'm backing up that. Here's all the repulpability data with it. So it's taken a little bit of time, because clearly, you know, the market has been sort of moving around looking for solutions and trying different things. And we would just happen to be one of them. I think what's happening now is that they're beginning to realize that, hey, this is a really good solution, because we don't have to fundamentally change much in the supply chain. Yeah. And the message to the consumer is place it in your paper waste. It's not a problem. And the waste guys are beginning to realize that this is a value stream to them, that if they can pull this material out, hydropole coated paper out, which is readily identifiable in IR, for example, that they've actually got an income stream, because the mills want it. They want increase in recycled content, but what they don't want is excess plastic entering their system. Well, with hydropole, you don't get that.
And I guess because it's a paper-based solution, the communication for consumers about how to deal with it in its end of life is straightforward. It's not like a plastic-based one where you're not sure what to do with it. It clearly goes in the paper waste stream, I guess.
Yeah, and I think, you know, Paul, we all know that, you know, as a sort of average consumer, if you like, who just looks at something, doesn't realize it's got, say, a coating on it or something functional on it. It just looks like a piece of paper, and as far as they're concerned, it goes in the paper stream. Well, that has and can cause issues if that's the wrong type of material. And clearly the waste sector and the paper mills already deal with that by rejecting that at the front end before it enters their paper stick, trying to minimize the amount of excessive contamination in their system that causes an issue. The beauty of hydropol is that they know they're not going to have a problem. So they can take as much of it as they want, and they're going to recover all of the fiber.
Great. So you've talked about some of the market testing you've already done. So
yeah.
What are the applications for hydropol and Aquapak? You know, what kind of products can utilize this technology?
I think pretty much anything. The only thing that hydropol won't do, if you like, is it has a high water vapor transmission rate. So any material which needs to retain moisture or water in some respects is clearly not what's going to be used for pure hydropol. I mean, there are obviously combinations of other materials we can place on there that will do the WVTR. But basically anything, what we're strong on is oils, fats, greases, waxes, solvents, and oxygen, carbon dioxide, nitrogen barriers. That's what hydropol is exceptionally good at. So where you've got products on the market that exist, so for example, EVOH, which has good barrier properties, doesn't particularly have good tensile properties. So hydropol has the good tensile property as well as heat seal. And it's also got anti-stat as well. So you're kind of ticking a number of properties in one go. But WVTR is the one where we would have to work with another material to get it to do that.
Okay. And all other barrier properties are comparable or better than what it's replacing?
Yeah, they're certainly as good in many cases. In some cases, we've found to be better. The thermal process of this material is for those of anybody that knows or thinks they know polyvinyl alcohol, is we've thrown the book away basically because we've just basically proved that if you thermally process this material, it performs differently to say solution cast, for example. So barriers are better, tensiles are better, heat seals are better, all that sort of stuff is better. And interestingly, on some things like oxygen, what we found in certain constructions is that at high humidity, it retains more oxygen barrier than you would expect a normal hydrophilic type material like EVOH or some of the PVOHs to do. And it's down to the process chemistry. Okay,
out of interest, I mean, you've been talking a lot about the technology and the research and development. I mean, how many years of development has this been ongoing?
Yeah, I mean, there's 10 years of R&D behind this, you know. So as always with magic solutions that seemingly appear out of nowhere, they've been worked on for a number of years. So it's kind of 10 years below the radar, and I'd say probably 3 years semi below the radar, I suppose. And really, you know, proper commercial product launches started in 2018, and it's now started to accelerate from there, really.
So you were really ahead of the curve in terms of anticipating the market drive to these type of solutions, you know, if you were developing these things 10 years ago.
Yeah, I guess I'd like to claim that we actually thought of that, but it just happens, I think we were one of those things where we were just working on a material which we thought was really, really interesting from functionality and end of life, but there was kind of no joined up bits in between that. And I think that's happened over the years we've been developing the product.
Yeah. Perfect. And when we talk about the past and the present, I mean, where do you sort of see Aquapak and hydropol within the next 5 years or so? I mean, do you see it sort of having a significant market presence, or, you know, will there be further iterations developed? I mean, tell me a bit more.
Yeah, there's I mean, we've got successful R&D programs already running in other areas. So, for example, rigids, injection molding, thermoforming, blow molding, but also fibers, non-wovens, and things like that. And that's looking very, very promising. And then other combinations with other materials as well looks also quite interesting in terms of giving them perhaps functionality they don't have. So yeah, I think, you know, from our perspective, it's almost, you know, it's reached that tipping point. I think it's accelerating extremely hard, and I think, you know, our investors, we're backed by significant private investors, and in fact, you know, laterally in December we Kibis fund came in, who are an impact sustainability fund. So they came in December, and I think what we see is that we'll roll this out across globally. We've already got sales activity and projects in North America. Obviously, we're already commercially active in Australia and Southeast Asia. And Europe's been actually the one that's played catch up, so which is what it's doing at the moment.
Okay, brilliant. That's really, really interesting. And thank you very much for your time. What would be the best way for people to get hold of you?
I think go on the website, all the contact details are on there. We're also quite available on things like LinkedIn, Twitter, etc., and things like that. So you can get hold of us really easily, just aquapakpolymers.com.
Okay. John Williams, ThePackHub Polymers, thank you very much for your time.